So today we are going to learn about parametric equations. What are parametric equations? Okay, parametric equations are two functions which are dependent on a common parameter. For example, let's say x equals f of t and y equals g of t. Now, if you are able to notice that in both the cases the parameter is t, so these two can be called parametric equations. Now, the question is, how are we supposed to find the gradient of a curve? So let's say there's a curve, and in this scenario, we have y over here, which is actually defined by the function g of t, where the parameter is t, and then we have x over here, which is defined by the function f of t, where the parameter is t. So how are we supposed to find the gradient of the curve on any point, basically on any single point, which we can actually do by calculating the dy over dx, taking out the derivative of the equation. But in this case, the y is actually defined in terms of t, not in terms of x. So in this case, what we actually have to do is, first of all, we will calculate dy over dt, dx over dt. So let me try to explain this through an example. Let's say x equals t square and y equals t plus 1. So in this scenario, first of all, we are going to derive the derivative of x in terms of t. So we are going to differentiate x with respect to t, dx over dt. Simply, we will be able to find 2t. And after that, we will find the derivative of y with respect to t. So we will differentiate y. We will find the dy over dt, which is going to be 1. Now, if you may realize that we can use a chain rule over here, which is actually dy over dt equals dy over dx multiplied by dx over dd. Now, how is it going to help us? First of all, you must have to realize that these two sides are equal. And how is that equal? If we actually cancel these both, this will also become dy over dt. So in order to find dy over dx, we will rearrange this chain rule and form this in this way, where dy over dt will be divided by dx over dt. So let's apply this on this example. In this case, we are trying to find the dy over dx. So we are supposed to divide dy over dt, which is 1, by dx over dt, which is 2d. Therefore, we are able to actually find the dy over dx. And this is how we can do. So let's go with another example. So here x equals 1 over t plus 1 and y equals t square. Now we are supposed to find dy over dx as well as d, basically the double derivative as well. So first of all, we will rearrange the way x is written. Okay, then we will try to find the dx over dt. Here we go. And the final result that we will get is actually minus 1 over t plus 1 whole square. Okay, now we will try to find the dy over dt as well. which is going to be 2t. And as we just did before, we are actually going to divide the dy over dt by dx over dt in order to find the dy over dx. So, okay. Now, actually, we need to rearrange this a bit because this is being divided in such a way that we can actually move this upside. So this will be our final result. Okay. So now we have dy over dx, and we need to find the double derivative. So in order to do this, first of all, we will simply differentiate dy over dx with respect to x. Here we go. But there is a problem. We are differentiating with respect to x, but the equation is with respect to t. So the parameter is different. So we will actually have to arrange it a little bit. We will try to play a game. We will actually differentiate the equation with respect to t first, and then we will simply multiply it by dt over dx. Or you can also say it as divide by dx over dt, because this is actually the reciprocal of dx over dt. So let's do this. Using the u into v rule, which is product rule, we will be able to differentiate this. So our u in this case is 2t minus 2t, and v is t plus 1 whole square. So let's do this. Okay, minus 2t into v prime, which is actually the differentiate of t plus 1 whole square. So we will end up with this. Okay, then plus v into minus 2. So we will get the result minus 4 t square minus 4 t plus, or maybe minus 2 into t square plus 2t plus 1. Let's simplify it a little bit more. Minus 4t square minus 4t minus 2t square minus 4t minus 2. So let's simplify this a little bit more. We will end up with minus 6t square minus 8t minus 2. After this, we will multiply it with dt over dx, which will be the reciprocal of this. So it will actually be minus t plus 1 whole square. So if we take out the minus common from this equation, we can actually simplify it to this way. Okay, now how was I able to come to this expression from this? It's basically I took the minus common from here, and we have already a minus over here, and simply by actually two minuses together will become a plus. So minus got cancelled. So let's try to simplify this a little bit more. So we will actually take 2 common out of the expression. 2 taken common, we will be left with 3t squared plus 4t plus 1 into t plus 1 whole square. So if we try to factorize this term, we can simplify this expression a little bit more. So let's do this. 3t squared plus 3t plus t plus 1 into t plus 1 whole square. So if we are able to realize that 3t is actually common in these two terms, so we will take 3t common, we will be left with t plus 1. And in this terms, we don't have anything common, so we will simply take plus 1 out of this term. You'll be left with t plus 1. So if we are able to realize, we will be able to form 3t plus 1 into t plus 1. So t plus 1 is already present with the power of 2, and another t plus 1, if multiplied into it, will give us t plus 1 cube into 2. So here is our double derivative. So I hope you enjoyed this video and it was helpful to you. Please share this video and also subscribe to the channel. Thank you.